Let's answer part A. Here we have to determine the equation of the tangent line to k at x equal to 6. So if you look at this diagrammatically, this is the graph of the k of x, of the function k of x, and this is the equation, or this is the tangent line which touches the curve at x equal to 6. So you can see that the slope of the curve at x equal to 6 equals the slope of the tangent line at x equal to 6. So first what we do is for finding the equation of tangent line, we need two information. That is, we need the point as well as the slope of the tangent. And from the figure, we know that the slope of the tangent or the slope of the curve equals slope of the tangent. So first let's find the slope of the curve. For this, we can use the k of x, which is the equation of the k of x. So we can find the slope. This is k of x equals f of g of x. And for a function f of x, suppose if we have a function f of x, its slope is determined by f prime of x. So similarly, for the function k of x, its slope is determined by k prime of x. So we have to first find a k prime of x by differentiating both sides with respect to x. So I'm finding k prime of x by differentiating k of x, and this equals, and this side also I should differentiate with respect to x. Here it is a composite function f of g of x. So I have to use the chain rule. So first I put f prime of g of x and then multiplied with the derivative of the inside part, which is g of x. Its derivative is g prime of x. And since we have to determine the slope of the curve at x equal to 6, we have to plug in x equal to 6 into this slope, so that we get k prime of 6, and this equals f prime of g of 6. Replace all x by 6, and then g prime of 6. So let's determine this from the table. So first I put f prime of g of x. Let's find g of x. So this column represent g of x, and at x equal to 6, g of 6 is 3. So I'm going to plug in g of 6 equals 3. So therefore this becomes f prime of 3 times, now we have to find g prime of 6. So once again we will find this from the table, and now I'm going to use this column g prime of 6, g prime of x at x equal to 6. So this is the value, that is -1. So I'm going to put -1 here. Now this becomes f prime of 3. We can find this from the table. So for that, I'm going to use this column. And since I have to find f prime of 3, I'm going to look at for x equal to 3. So therefore, f prime of 3 is 7. So we get 7 times -1, and this equals -7. So we found the slope of the curve at x equal to 6 is -7. And this means the slope of the tangent is also -7. Okay, so now that we have determined the slope, we need the point. So we can find the point, that is, we have the x coordinate of the point is 6, but we want the y coordinate. Y coordinate is basically k of 6. So let's determine this. So this becomes y equal. For that, I'm going to copy this k of x. K of x is f of g of x. So therefore, k of 6 will become f of g of 6. We have to replace x by 6. And so this becomes, we know that g of 6 is 3. So I'm going to plug in g of 6 as 3. And therefore this becomes f of 3, which we can find from the table. So look at this column and find for x equal to 3. And it is 8. So f of 3 is 8. And this means the coordinate is 6 comma 8, or the point is 6 comma 8, and the slope we have already determined as m equal to -7. So now we have a point and a slope. We can use the point slope form of a line, that is y minus y1 equals m times of x minus x1. So I'm going to plug in this is x1 y1. y1 as 8, so it becomes y minus 8, and this equals m is the slope of the tangent, which is negative 7 times x minus x1 is 6. So let's simplify this. We get y minus 8, and this equals negative 7x plus 6 times negative 7 times negative 6 is 42. Let's add 8 to both sides and put this in the y equal to mx plus b form. So we get y equals negative 7x plus 42 plus 8 is 50. So this is the equation of the tangent line to the curve at the point x equal to 6. That is y equals negative 7x plus 50. Let's answer part B. Here we have this function h of x equals g of x plus 2 over f of x plus 1 quantity square, and we have to determine f h prime of 1. So first we have to find h prime of x. We can find this by derivating the h of x. So let's find the derivative of h of x, and this equals h prime of x. And we have to find the derivative on of the right side expression. For this, we can use the quotient rule. That is the quotient rule of differentiation. That is, if we have u over v and its derivative is given by v u prime minus u v prime over v squared, where u prime is the derivative of u and v prime is the derivative of v. So we can consider this expression, that is the numerator expression as u and the denominator expression as v. So when we use the rule, we have to first plug in the denominator expression as it is. So I put the denominator expression is f of x plus 1 quantity squared multiply with the derivative of u, which is the derivative of g of x plus 2. Its derivative is, we have to find the derivative of g of x, which is g prime of x, and the derivative of 2 is 0. So therefore the derivative of g of x plus 2 is g prime of x. So I multiply with g prime of x, and then we have this negative in the formula. So I put the negative. Now I put u, which is the numerator expression, that is g of x plus 2 within the brackets, multiplied with the derivative of the denominator expression. That is, we find the derivative of f of x plus 1 quantity square. Let's do that here. That is f of x plus 1 quantity square. So first, to find this derivative, we have to apply the power rule. That is, we have to put this power in front and reduce it by 1. So when we do that, we get 2 times of f of x plus 1 raised to the power of 2 minus 1, which is 1. Otherwise, we just put this expression as it is, and then multiplied with the derivative of inside part. That is, we go by the chain rule. So that's why we have to multiply by the derivative of the inside part. The derivative of the inside part is f prime of x, because the derivative of 1 is 0. So this is what we get when we derivative the f of x plus 1 quantity square. I'm going to put that over here. That is, we have a 2 in front, f of x plus 1 times f prime of x. And then we put this division symbol over v square, that is the denominator quantity square, that is f of x plus 1 quantity square. But this has to be quantity square because v is f of x plus 1 quantity square, but according to the quotient rule we have to find its quantity square. So let's simplify this. So I clear this for some space. I'm going to clear this and rewrite h prime of x, and this equals, we have f of x plus 1 quantity square times g prime of x minus this is 2 times of, I put this 2 in front, g of x plus 2 times f of x plus 1 times f prime of x, and this is all over f of x plus 1. This is 2 power 2 is 4. That is, these two powers will get multiplied. So it is raised to the power of 4. Now, since we want to find h prime of 1, we can replace all x by 1 here, so that we get h prime of 1. So this equals, I'm going to replace all x by 1. This will become f of 1 plus 1 quantity square times g prime of 1 minus 2 times of g of 1 plus 2 times f of 1 plus 1 times f prime of 1, and this is all over f of 1 plus 1 raised to the power of 4. Observe that we have this expression coming both in the numerator as well as the denominator. So I'm going to evaluate this separately and put this into this h prime of 1. So first let's calculate f of 1 plus 1. We can use the table for this. We have to find f of 1. So look at this column f of x. At x equal to 1, it is negative 2. So therefore this becomes negative 2 plus 1, and this means negative 1. So f of 1 plus 1 is negative 1, and this means all this can be replaced by negative 1. So we get h prime of 1, and this equals, I replace this quantity by negative 1. It becomes negative 1 quantity square times g prime of 1. We can get this from the table. So look at this g prime of x column, and then we have to do g prime of 1. G prime of 1 is basically 8. So let me plug in 8 here. We then have minus 2 times of g of 1 plus 2. G of 1 is 2. So 2 plus 1 is, I'm sorry, 2 plus 2 is 4. We know that f of 1 plus 1 is negative 1. So I put negative 1 times f prime of 1. Let's find it from the table. This is f prime of x, and we have to find f prime of 1, which is 3. So I put 3 here, and this is all over. F of 1 plus 1 is negative 1. This is raised to the power of 4. So let's evaluate this. So we have h prime of 1, and this equals negative 1 quantity square is a positive 1, and 1 times 8 is 8. So I put 8 here. We have negative, and we also have negative. So product of two negative is positive. So I put 2. I'm sorry, I put positive, and 2 times of 4 is 8. 8 times of 3 is 24. So I put 24, and this is all over negative 1 raised to the power of 4, which is even power, and this is going to be positive 1. So this is 8 plus 24 over 1. 8 plus 24 is 32. So 32 over 1 equals 32. So we have determined that h prime of 1 equals 32. In part C, we evaluate this integral, that is the definite integral from 2 to 6 f double prime of half x dx. So we are going to integrate this by method of substitution. So first I'm going to put half x, and this equals u. Now I take the differentials on both sides, so I get half times of differential of x is dx, and differential of u is du. And this implies I can solve for dx, that is dx equals 2 du. And this means I can now replace this dx by 2 du, as well as this half x by u. And we will also have to change the limits since we have made the substitution. That is, when x equal to 2, let's find the corresponding u by plugging into this substitution. So therefore it will become 1 by 2 times of replace x by 2, and this equals u. That is, these two gets cancelled, so we get 1. 1 times of 1 is 1. So when x equal to 2, u equal to 1. And similarly we should find for the upper bound, that is when x equal to 6, we get half of 6 equals u, that is 3. So we get u equal to 3. This is the corresponding value of u when x equal to 6. So let's change this integral, or we rewrite this integral after we made this substitution. Therefore, we get this integral from u equal to 1 to 3. This becomes u equal to 1 to 3, and f double prime of half x is replaced as u, so therefore it becomes f double prime of u, and then dx we replace it as 2 du. So I put 2 du here. Now I can factor out the 2 in front, that is out of the integral. It becomes 1 to 3 f double prime of u du. Now we can integrate this by conceptual method. That is, if we have a function and its derivative is f prime of x, and if we find the antiderivative, it is equivalent to the original function f of x. That is, if you find the derivative, I'm sorry, if you find the integral of f prime of x, we get f of x. And similarly, this is the second derivative of the function f of u. So when we integrate this second derivative, we get the first derivative. So we can put this as 2 times of f prime of u, and this must be evaluated from 1 to 3. So let's apply the limits now. So therefore this becomes 2 times of f prime of, in place of u we put 3, so it becomes f prime of 3, and let's apply the lower bound now. So therefore this becomes f prime of, replace u by 1, it's become f prime of 1. Now we can put these values by looking from the table. We should find f prime of 3 and f prime of 1. So let's look at only this column. F prime of 3 is 7, and f prime of 1, which is 3. So I put 7 minus 3. This is 2 times of 7 minus 3 equals 2 times of 7 minus 3 is 4. So this gives 2 times 4 is 8. So we found the, or we evaluated the given integral, which is 8.